Welcome to the structural tee, a part that tests all weld positions held in a fixed position. This is the structural tee, a final project that tests structural welding and fabricating ability. This picture is three views of the object. This will be constructed from 3/8 plate, except the pipe sections, which are 3-inch diameter Schedule 40 pipe. This project will be welded in position, which means that once it is tacked up, you must weld it out completely in that position. It will be fixed at shoulder height, so consider carefully the height that you set it at so that you can comfortably reach all parts of the workpiece. This will be welded out using either 6010 or 6011 or TIG root and a 7018 cover, or MIG solid core with gas coverage, or MIG flux core. It will be your choice which process you prefer to use in this project. This part will be tacked out on the table or bench, and it must be laid out according to the print before being tacked up to weld. In this view, you can see all the parts in relation as they will be tacked in place except for the pipe flanges. This part is designed to test all the weld positions in one part. As you can see, there are 1F, 2F, 3F, and 4F, plus the 5F with the pipe. If a student chooses to increase difficulty, the part can be oriented with the pipes at 45 degrees so that the pipe weld becomes effectively a 6F. All parts must be tacked and then reviewed by the instructors for approval before welding. If it does not pass, it will need to be broken apart and re-tacked. So, do not over-tack. Tacks need to be good enough to hold in the correct position, yet not so hard that you cannot break them if need be. All parts need to be in perfect orientation. In beginning the structural tee project, the first thing you want to do is we want to look at the parts that we need to make this piece, lay them out, and check them against what's on the print. Do not assume that just because these were pre-cut parts that they are correct. You should never assume that. So looking at the print, check all your dimensions and make sure they're correct. Make sure these are actually square because it could be miscut. Assuming that all the parts are correct to the print is something that can land you in some really hot water, because if the part was miscut by the person supposed to supply you with parts, now you're stuck with that error and you've missed it and incorporated it into your work. So check all your dimensions, make sure they're correct, you've got the right number of parts and the right size. You can see clearly right here, this one is not according to the print. It is the correct diameter of pipe, the correct thickness, but the length is wrong. So you would need to get another one. This is a very, very important thing. The next thing you want to do is remember that wherever your parts are going to be welded, you need to remove a 1/2 inch of the mill scale and the surface from all the parts. So even though these are clean metal, there's no mill scale on there, there's still skin on there, and there's still quite a bit of oil which needs to be removed. So this side, here, 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 any edge that is going to be touching the liquid metal needs to be cleaned thoroughly before use. Also, check for burrs. Little burrs sticking out from the cutting process may not allow the part to sit evenly when you tack it up. They may be leaning one to another or even fall over. So check for burrs, remove them if necessary. Make sure your parts are correct before you lay them out. On the pipe is going to have a very heavy layer of scale. Again, remove at least a 1/2 inch around the edge before you begin. Remove any burrs that are around the edge of the pipe because then it will not sit flat. The first thing to do is look carefully at the prints. The title box will lay out the rules that we need to follow, like the tolerances, and the notes have important guidelines on how the part is to be made. These need to be followed strictly, and you need to look at them again and again throughout the building and welding to make sure everything is following the print within the stated tolerances. If there is anything on the print that you do not understand, get help immediately before you proceed. Parts can be very expensive, and the process of making and welding can be dangerous, so if you are ever in doubt, seek help. On a multi-part print such as this one, the measurements or instructions may be spread out over several pages, so you must read all the prints to get an accurate view of the object as a whole. In a print, you must look at more than one view to see the true shape and true dimensions of an object. There are special instructions in the notes section on this print that you must do to the parts. Students often rush through the build and only after realize they missed a step. Make sure you are moving carefully and slowly. This last print incorporates G, D, and T requirements into the print. These have to do with the flanges, which are a critical part that must be aligned precisely. This kind of process is very common and it is good to know how to do it. The following pictures have good details on how this is done. It is critical to take the time to read the print and set up the parts and tack. Note how the tacks are arranged at exact orientations to the part. Tacks are not random. They are placed to make reversal easy if necessary and allow welding passes to cover easily. Sometimes it is advantageous to feather down tacks before welding so bumps are not created. The tacking and fit up is only as good as the surface you set up on and the tools you lay out with, so take care to choose your workspace and set your tools up right. The lower part labeled invisible is the part that only the fabricator in the shop sees and is involved with. It is important to keep in mind that the large part below the green line is not on the print and very often there are no instructions given for this. The fabricator must draw on their knowledge and experience and sometimes research to successfully build the part by using these techniques effectively and skillfully. This encompasses making special tools or setups called fixtures, sometimes having to make subassemblies of the parts and then combine them later. As can be seen, this invisible part takes up the majority of the time and effort in fabricating and welding, and is sometimes something the client will never see, nor should they. At the highest degree of skill, a fabricator's work is truly invisible, and the evidence of that labor should never be visible on the part. This means no grind marks, scratches, fingerprints, or dents. This part replicates common joints and situations encountered in structural work, which covers buildings, bridges, towers, and marine vessels. Basically, anything people can go into or on. In this picture, the pipe welds can clearly be seen, and the vertical welds on the inside as well. The part has been suspended in the booth at the height chosen by the student. All welds are done without moving the parts, so make sure you can get to the rear and inside of the part. Real life situations are often awkward and difficult to access. This detail of the 5F weld shows excellent form. The beads are tight and even and the tie-ins are well executed. This is a 7018 weld done in a 5F position, and is an example of what you should be striving for. Make sure you practice the position until you can do this. A MIG weld will look close enough that this is still a good model to use. A key thing here is setting so that your body is well supported and not shaking or out of balance. In the diagram above, the pipe is divided into quadrants and each section is welded in order. The welds are always vertical up. In this picture, it can be clearly seen how the welder set up the part to allow access on all sides, and it is set at a height that allows it to be used as a rest. Careful consideration of these things is critical to success. The welder has completed the basic welded part and is setting up to do a 6G weld on both pipe sections. The welder is carefully grinding and feathering the tacks before welding the root pass. The root pass was done with TIG, then followed with 7018. This is a common procedure with pipe, but students could also execute this with 6010 or 6011 root and 7018 cover. Another view of weld joint preparation before welding. 1/2 inch to either side of the weld joint should be cleaned of all scale. The welder in action. Look how steady the body is, the relaxed posture in the supporting arm. Click on image to see video. Here, the welder is positioned to come up from the bottom. This can be quite challenging without practice. It is recommended to dry run the weld first to make sure body position is good and you are comfortable in that position. It can be helpful to work in a pair assisting each other. The welder's elbows are held close to the body, legs out to balance. One welder is preparing to tack while the other is aligning the level and flange. Note how the part is securely fastened to the table. No part should ever be freely resting but must always be secured for safety. Here is another advanced exercise. Here the welders are working together to level the flange to the earth with the level after it has been made concentric with the pipe and perpendicular to it. This requires careful work and attention to details. Click on image for video. Here is a close-up view of the method to align bolt holes correctly. A pair of bolts is used to level the holes. This is useful as flanges can be aligned to the earth around a corner or through a wall quite easily. Here is another view where the completed 6G weld is seen. It is done with two overlapping welds. Keep in mind that if using 7018, the weld may not exceed 3 times the rod diameter in width, nor exceed 1/8 inch in height above the surface. If you're using MIG, The maximum width is 1/2 an inch and 1/8 inch in height. Using a level and other measuring tools repeatedly throughout the project is essential. Measuring is not just for the beginning layout and tacking of a job, but used continuously to guard against errors. If the print is followed correctly, all parts will be identical. This can be checked by bolting 2 or more completed units together, and all will be aligned on 90-degree axes. In this picture, the upper flanges are bolted together, and the lower ones rest completely flat on the table. This is the ideal result to this project. Thank you very much.